It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I always say, as always, my co-host Andy Grabner is here. Hello, Andy.
Hello, this is Andy Grabner.
Hi, Andy Grabner. I don't know why we're doing goofy voices. It's goofy. Today is actually International Goofy Voice Day. I just made that up. I just declared it, and since my alias is Emperor, that it is true now. You're back over in Austria now for a little while, right, Andy? You get a little break?
Yeah, a couple of days. Well, officially I live here again.
You live there, but you're never there.
Yeah. I'll try to be here a little more often because obviously Gabi and I made the choice, so the decision to move to Austria. So we should stay a little bit more here. My parents would enjoy it as well.
Yeah, I'm sure.
If they don't if they actually see me more often. But still, flying around, educating the world, and trying to help folks in the stuff that we do, right? Talking about performance.
And speaking of your mom, everybody remember to call your mom. I don't know why I said that, but it's something people should always do, right? Because I'm sure they're... Yeah. Anyway, yes, speaking of performance, right? And we got are we going to talk about performance today, Andy?
I would believe so, right? Because basically everything we really do, not only us, but also our guest today, I assume that Justin is his name, and I will give him in a second a chance to introduce himself. I'm pretty sure everything we do in some places somehow should have performance in mind, whatever that means. So Justin, are you there with us? And would you mind introducing yourself?
Yeah, I'm Justin Donohoo. I'm one of the co-founders at a company called Observian. We're an AWS partner and a software delivery company where we help people focus on just delivering software better. Been doing serverless for quite a bit. I've run the serverless framework meetup here in Salt Lake City. So thanks for having me on today.
Cool. Actually, on your website, if you go to observian.com and then on the About page, I think you mentioned it, but you actually do cloud better. You not only help people to deploy better software, but you do cloud better, and you have some cool things on there. And as you know, AWS, obviously one of the big cloud vendors, and their Lambda service. Is this stuff that you do exclusively with AWS, or do you help people in general, whatever public or enterprise cloud environment they choose?
So when it comes to serverless, right now, from a tooling aspect, AWS has the most tooling, if you will, and some other cool things that you can do to get around some limitations that I can talk about later. We do dabble in the Azure and Google space, but the bigger shift that I'm seeing is there's a lot of customers that are still trying to do on-prem VMs, and we're helping them transition into more of a container architecture. So most of our serverless projects end up being cloud native. Anybody running in the cloud, we're not running any of the open function platforms or anything on-prem with customers. If they want to go a more serverless route, we kind of nudge them into the cloud like, hey, here's why you should go here, and here's the benefits.
So do you see, this is interesting, I mean, obviously serverless is a hot topic, and we've been talking about it for a while. And if anybody, wants to kind of get a little, let's call it maybe a one-on-one, then Brian, we did an episode with Daniel. We did a one-on-one. What was that episode again?
Yeah, let me take a look in this chat here. That was episode number 42. Oh, 42. What an apropos 42. Number. Episode number 42, Serverless 101. It's funny. Every time you say 101, I think you say one-on-one. And it reminds me of the Hall & Oates song. But anyone can go listen to that. But yes, episode 42, Serverless 101. There's also several other episodes. We covered some other serverless topics. But I think we're going to be looking at some new things today. So,
so Justin, what I heard, and I think you just mentioned it as well, right? People are excited about this technology, and then you realize what they are actually doing right now is a couple of steps away from where maybe this new technology can bring them. And how do you approach projects, and what are the lessons learned in getting people to actually leverage a new technology, whether it's going to be serverless in the end, or as you call it, cloud native using microservices, or whatever it is? What are the lessons learned, and how can people get started? What are the things that we can tell the audience?
Yeah, so one of the first things I recommend people do is let's save yourself a ton of time and heartache and just go straight to serverless.com and start using that framework. Mm-hmm. The framework takes a lot of the complexity and makes it easy to organize projects and deployments. When you're talking serverless, we're mixing a lot of technologies together. Like we're doing CloudFront, we're doing static hosted S3, we're doing API gateway talking to Lambda functions. We might be doing Cognito for authentication. Like there's just a lot of AWS services. Managing that in just your own repo and doing it by hand is atrocious. So I just kind of route people to the framework. It's based on CloudFormation. If people aren't really that familiar with AWS, think of it as their infrastructure as code. And what you have is a nice, elegant YAML file where you can define your functions and like your API endpoints. And when you just do serverless deploy, it'll create a CloudFormation stack and send it out for you. Versus trying to be like, okay, I have 5 Lambdas, I need 5 API gateways. Do I do 5 separate ones, or is it all one? And like all that management is a nightmare. It goes away. Also, like repo structure, I've seen different projects where some people try to do, hey, we're going to have one function per repo. It seems good on paper, but it becomes a management nightmare. You have like what I call repo sprawl. And so if you go into there's a couple different patterns we can talk about, but a good, repo per service or repo per, logical grouping, like a user service or a a product service where you're doing logical grouping. So you might have n plus 1 Lambdas, but they're all related to this one thing and they deploy as a unit. It's a little bit better.
So can I ask a quick question? So the serverless, I've actually just recorded a YouTube tutorial last week with Daniel Kahn, one of our guys who is, kind of our technical expert and advocate for Node.js and serverless. And he also used the serverless framework. So I was actually very excited to see it and completely agree with what you said, right? You write your YAML file and then serverless automatically creates all the boilerplating for you or the CloudFormation template. The only question that I had, and I didn't, I think, get Daniel to ask. So if I use serverless and I create my first version, I create my CloudFormation template, and if I make changes, is serverless, I assume, smart enough to just update my CloudFormation template? So I just update the stack, or do I have to completely recreate that stack every time when I deploy a change, or how does this work?
So when you are doing your serverless deployments, you have an S3 bucket, which basically keeps the metadata about that deployed unit. And when I do serverless deploy again, all it's doing is a CloudFormation change set. So yeah, it'll just update the stack and redeploy the changes.
That's perfect. Cool. And so I think serverless.com, is that the place to find more? Yep.
Yeah, I was just checking that out. They also list, I'm sure it's probably still not as heavily used, but they do list the full suite of, Google Cloud Platform, Azure, IBM Cloud, and Kubernetes along with AWS, obviously. So it looks like they're expanding as well in some aspects.
They definitely offer touch points with all of your major cloud providers. It's pretty powerful. You have one framework that kind of, in your YAML, you just define the provider, and it's literally switching between cloud providers. So you can kind of play with it.
And so to some of the architectural patterns, because you said, on paper, it may look interesting to start with individual projects, which are individual serverless functions. But then I think, as you said, it makes much more sense to kind of group them together. How does any additional best practices that you have around here, especially when it comes to, quote unquote, refactoring? What if you are realizing that at some point you need to move things around between different projects? So how do you structure a project then? Is it just from an organizational perspective, you structure certain functions together, or is there another framework on top that kind of aggregates functions that logically belong together into a single entity? How would that work?
So one of the things that I try to do is I specifically only do my serverless in .NET Core and Java. I'm trying to show people that you can do serverless in the enterprise. I also do it in Node, but the main reason I focus on the more compiled runtimes is because there's not so many functions and let's say examples out there. But if I want a Node or a Python example, you can find thousands of them on your first Google hit. So for the different design patterns, one of the things that I found that to keep it just logically grouped in my head is I architect my projects almost like it's an MVC project, so your standard model view controller, where the handler, I treat it like the controller. So you make sure that the controller/handler is dumb. It's almost a pass-through. All it should be doing is initializing business logic classes and functions that are calling into your model to interact with, database, other third-party REST APIs. And so that's how I structure the project. So you have, let's say, a user class. It might have a create user method. It might have an update user method. And then you can have these different handlers just pass through their logic to these methods. As far as actual design patterns, this is where it's going to be kind of a long-winded answer, so chime in. I've got what I've categorized as 4 different design patterns that people are doing. It doesn't matter what language you're in. This is purely just serverless topics. So the first one is, I'd say, your traditional microservice, but I kind of coin it a nano service. And what it is a single Lambda per function with a single API endpoint per function. So the pros to this approach is you've got separation of concerns down to like the functional unit. It's easy to debug because it's an individual function. It's pretty easy to test because you just have one input, one output. And it's really easy to deploy changes to the system to just a single function. So that's all the pros. Now, if you want to talk about the cons with this pattern, one of the dirty secrets of serverless is cold starts. When you're dealing with a cold start, it's pretty noticeable. Like I've seen cold starts take several seconds, but once the container is warm, if you will, it takes, a couple milliseconds. So when you're running an API that's in this nano architecture, you have a lot of functions as you grow, so you can get function sprawl. You have risk of hitting CloudFormation limits because there's a file size as well as a resource count. Your full environment from scratch, if you want to deploy the whole thing, takes longer because you have to deploy each Lambda one at a time. And this architecture pattern has the highest probability of cold starts because it has the most endpoints and the most functions. Does that kind of make sense there?
It does make sense. And how did you call it again?
So that's a microservice nano pattern.
Microservice.
So that's where you do it pure one-to-one. So I have one RESTful endpoint that maps to one Lambda function.
Yeah, and then the limits that you said on the CloudFormation, this is because you have so many CloudFormation scripts, obviously, because for every single function, you have to create or update a CloudFormation template, and these are obviously the overhead alone of the whole orchestration of the CloudFormation template. I guess that's where the limit is. Or is there actually a hard limit on the number of CloudFormation stacks you can create and manage within an availability zone?
Well, it's also the fact that if you're using the serverless framework, there's a way around it, right? So if I'm using a serverless framework where I've mapped out my whole API and it's one-to-one, one function each, the problem is it's actually a single CloudFormation file, and you can hit file size limits and resource count limits. A workaround, I guess, would be one serverless project per function, and now that you have like 50 projects floating around, it becomes a management nightmare.
Yeah.
Hey, let me ask a question on it, because you're talking about the one-to-one, right? Now, if we take a step back to containers, right? I mean, not containers, sorry, back to microservices. One thing we know in microservice design is that if we have one-to-one service calls, we really don't want to split those into separate microservices, because from a network point of view, from a resources point of view, if every single call hitting service 1 always goes to service 2, it makes a lot more sense to keep those together. How do you determine, or what are the pros and cons? You're saying you're doing a one-to-one, one endpoint. What are the pros and cons of that, of going it sounds like you're taking an opposite approach in the serverless, where you are splitting them out. Are there, just trying to wrap my head around, why that works in serverless but not in microservices? Obviously, the shorter running your services, the less you get charged, but you're also then spinning them both up. So does it really balance out? Like, do you understand where I'm going with that? Or Andy probably at least does.
So the main benefit for getting this granular is as you're kind of doing a sandbox architecture where you're building serverless for the first time, there's some different learning curves that you can't really describe without going through it. And this allows you to optimize each function to the optimal settings for that function for the best price and performance. So if I lump, say, 5 lambdas together, I now have to optimize, or not lambdas, but you get what I mean. I have one function that handles 5 inputs. I have to optimize to the slowest or the highest memory usage function. So something that's, really lightweight might just be having this unnecessary overhead because another function that's inside it that's a possibility takes a lot more RAM. So we have to optimize to our slowest or worst offender, if you will.
So it's kind of like the noisy neighbor idea comes into the serverless, whereas in microservices, it wouldn't necessarily, but when you move back over to serverless, you can actually gain from having the quick ones go on their own. That's interesting. Yeah, I like that.
Because you can control the different aspects of concurrency as well as memory, timeout execution. There's a lot of little levers that you can pull in an individual Lambda function that when I'm in a more traditional microservice, I have to pull a lever and it usually impacts the whole service.
Yeah.
Cool. Yeah, this was so the microservice nano pattern. What's the next pattern?
So the next one is more of, it's called a service pattern. This is what I actually call a microservice. These are patterns that are referenced in documentation on serverless.com. I'm just going through kind of one of the talks I did at one of our meetups. So the service pattern that's really more of a microservice, what it is a single Lambda that can handle multiple scoped functions. So you have multiple API endpoints that point to a single function. So the pros are basically separation of concerns down to the service level. It's easy to deploy to a single service, and it reduces the number of cold start possibilities because we have more endpoints talking to a function. The cons is that now you have to write your own custom router. So your handler, the first thing it's got to do is look at the request and say, which function is this person actually trying to call? Which leads to increased debugging complexity because you have one input that could have multiple outputs. It's a little bit harder to test because, again, I have one function that has 4 or 5 different results. And the function's now grown in size, so there's more physical code. So when you make changes, there's a higher risk because, more code equals more risk when we deploy. But this is more of your traditional microservice. So I might have a Lambda that's like user. And the endpoints that are pointed at user are create user, update user, get user, or list users. Those handlers are all inside one Lambda function. Those endpoints all point to just the user function. And based off, is it a post, get, put, I have a router that's routing to the right function, if that makes sense.
Yeah, makes sense. And so technically, though, I fully understand you would probably use an API gateway, as you said, API gateway configuration to define all your different endpoints and then route it to, let's say, the same function handler. But technically, and I'm now just talking about Node.js because that's the most recent Lambda function that I've implemented. Can you tell me if I would be able to export in a simple Lambda project multiple handlers, or does it always have to be just one handler and it always has to go through the same handler and then the handler has to decide how to route it based on the request parameters? Or could I expose and export all of my different handlers to create, the update, the delete, as you said it earlier, as individual exported handlers, and then use the API gateway and say, here's this handler, and here's another handler, even though technically they're in the same serverless function. But I guess it's not possible, right?
Well, so what you just described is the nano pattern before, right? Where you have one endpoint talks to one handler. So, but to answer your question, it is possible. We run observing.com 100% on serverless, and it's Node.js background. And we've got like a hybrid where some functions are declared in our serverless project as a one-to-one. And like our blog that we're just rolling out is more of a service pattern. We have a blog that has all of the endpoints go to this one function. So the Lambdas themselves have their entry point, which is called the handler. And you can make it whatever you want, but This design pattern is specifically calling for we route everything to one handler, because one handler in this case means one Lambda function. So the first call, it has a cold start, it's up and running. Because we listed a user, now we want to add the user. Well, as long as we do it within 15 minutes, because that's about how long you've got a container inside Lambda going for, it's going to hit that same pre-warmed container. It's going to be much faster. So if I'm adding and editing users, that first initial hit was a little slow, but each one after that is much faster.
And how many parallel requests? How does this work from a scalability perspective? Let's assume I have 100, logical functions or endpoints that are all calling into the same handler. Is this does this mean how would a runtime like AWS be able to correctly scale this? It's probably pretty hard. You can just scale it based on
there's literally a number for concurrency.
Yeah.
You just say 10, right? So now it'll keep 10 of your Lambda containers warm, if you will. So 10 people at the exact same time hit it. They're going to hit their own instance of a container. The 11th guy might queue up for a second. When the other one's finished, he grabs the next one on the stack. Or if you have it, say, set to 15, and you have 10 people using it, that 11th person gets a cold start, and then they're going. It's pretty crazy. You have to be careful when you start doing serverless because of how easy it is to scale. You can DDoS people if you're not careful. If
I was just thinking that.
A high concurrency rating talking to a third-party API that doesn't throttle, you can literally take them down.
Yeah.
I was thinking too, besides taking them down, that's a great way to make them lose a lot of money as well, right? If you're constantly making them spin up more and more long-running Lambdas, that's going to cost a lot as well. So it's it also becomes a security concern besides the DDoS, the financial impact as well.
Oh yeah. It gets wild. So the mystery of, where the servers go, it means it's super secure, right? It's like, no, you still have to deal with SQL injections. You still have to authenticate your APIs. You still have to do smart throttling, or you can spin up thousands of dollars while nobody's watching it.
So you still have to use your brain, basically. That's what you're saying. If you architect something like this, Yeah.
That's what I was saying in a nice way, I guess.
Yeah, exactly.
Like, don't be stupid, people. One of the other things that I've ran into is, hey, all of these permissions in AWS are complicated. I'm just going to give my function admin access. What could go wrong? It's like, well, a lot. So there's some interesting things going on in serverless. PureSec has got some cool stuff in the space where they've come up with like a runtime that's doing inspection. It's a cool landscape. I'm kind of watching it as it emerges. One of the former Akamai execs, he's the CTO over there. He does a web series every once in a while. It's pretty cool. I would definitely check out PureSec if you're interested in security around serverless. It's not my forte.
How do you spell that? PureSec?
Yeah, like pure, P-U-R-E, and then sec, S-E-C.
Look at that, Brian. This is like pure path and pure stack. Now we have pure sec.
Right.
And pure performance.
And pure performance. Look at that. Hey, I got one more question on this. So does this mean that the container, the physical container that is actually, virtual container, whatever it is, that is actually spawned up by, let's say, AWS, can only handle one request at a time and then spins up another container in case I have concurrent requests, or depending on the runtime, Node.js, Java, or whatever it is, there's a multiple worker threads that can handle requests?
If you've dealt with like an IIS web server or like an Nginx, like when you're doing Node, you have your different child processes that are basically, instances of your service that you pass through, and that's how you can have multiple pools, right? Think of a virtual container that's how I describe it to people. It's like a managed virtual container. That's really what it is. You're not doing anything with it. There's servers behind the scenes, whatever. That's the nitty gritty. It's the same thing. If you have one of those virtual containers running, it can only handle one request, but it's not that big of a deal. You have your concurrency set to 10. It's like you can have 10 concurrent users. You can crank it up to 100. You have 100 concurrent users. The beauty of it is you're only paying for what you use. If it's like if you have tens of users coming to your website and your concurrency is 10, you have one or two people at any given time. If you start getting into the thousands of users, okay, you might have a couple hundred concurrent connections at once. You can just keep growing. I have one architecture that it grows with me. The cost grows with it, but if I don't have traffic, I don't pay that much. So as I get more traffic, I'm making more money. Yeah, it costs me a little more, but yeah, I'm making money.
Yeah,
it kind of delivers on the promise that cloud pretended to be for a long time, which was pay for what you use, and it's really always been pay for what you provision. So this finally brings pay for what you use to a reality for virtualized computing in the cloud.
Yeah, I love that what you just said. Pay for that. That's brilliant. Pay for what you use versus pay for what you provision. I never. I just wanted to repeat that because that's really, really amazing.
Yeah. And isn't that the same as in the mainframe times?
Yeah.
Right. If you think
going
about
back
it,
going back to mainframe, right?
Yeah, I'm not. Yeah, I mean, in the end, I'm not familiar. I mean, I didn't grow up in that time, but based on what I know, is that you obviously get the hardware and then you pay by MIPS, right? Whatever you use.
Yeah.
And it seems like a similar model. Cool. Hey, so we had the microservice nano pattern. We had the service pattern.
Yeah, I got two more.
Yeah, I got two more. Come on, shoot over.
Okay, so the one that is called monolithic, it probably turns people off just because of the name monolithic, right? So what is it? It's a single Lambda that basically handles everything. And that might sound crazy, but it's really not if you think about it. So it's all of your API endpoints point to one function. And if you think about how your traditional REST MVC frameworks work, this is literally what they're doing. You have one endpoint that's all funneling to one service, and you have, routing that passes off to the different controllers, which does the logic, right? So this is the fastest way to deploy an entire system because it's one Lambda. So if I go from 0 to hero or I switch regions, I'm deploying one giant Lambda that my website points at. It also has the lowest probability of a cold start because all of my API functions are going through the same Lambda. But where it starts to have cons, while it sounds great, is your custom router is getting pretty nasty because not only do you have to look at like your HTTP methods to see is this a put, post, get, delete, but is the URL user, is it product, is it login? You definitely risk hitting all the CloudFormation limits that we talked about before. Debugging gets much more complex because of all of the different inputs coming into one system. Testing becomes a lot of mocking that you have to do to make sure that you can handle every use case. And performance monitoring is all over the place. And this is probably the main reason I don't ever do this one, but it's an interesting concept that people do. I can't tell what's, good performance in this pattern because a login method that takes a few milliseconds versus something that's, running a database query, it's all in the same function. So you're going to have peaks and valleys and you can't really tune your performance. It goes back to tuning to my slowest running one.
I mean, that's where I want to interject quickly here, but that's obviously where, companies like Dynatrace, we are investing in automated tracing of your Lambda code as well, so that you can actually install our what we call one agent on your Lambdas, and then we automatically tell you which execution path, so which traces consume how much time, and which trace is actually executing a database statement versus not doing a whole lot. But I think we had a conversation in the beginning before we started recording. You also said that the tooling, there's a lot of tooling around serverless that is still in the very early and immature phases. There's obviously we try on our side to do our best to fill that gap. But I agree with you. Maybe if you have not seen some of the stuff we've done in the past, and I'm sure we're not doing yet a perfect job on every runtime that is out there. But I think just to let you know, there's stuff coming on our side to address this. So there's stuff out there already that you may want to look into.
Yeah, in this space, I mean, the APM players, AppD and Dynatrace, they both are doing a pretty good job at this. But the ecosystem as a whole, it's just lacking. It's just such an emerging tech. It's just like when containers were the new hotness and everybody was trying to do it, and it required complex sysadmins. And then Kubernetes comes out, right? Google's like, hey, here you go, just use this. And then it took off like wildfire because all I need is a Kubernetes endpoint. I can start shipping containers.
Yeah.
So I think the serverless technology, it's probably like 2 years out where you really see the tight integrations and the suites. I mean, there's random companies popping in the space like Dashboard that does a pretty good job of giving you dashboards of what's going on in your Lambda functions. Because there's got to be a balance, right? Like, I don't want to have 50 tools in my system just to monitor what I'm doing, but I also don't want to be digging through cloud trails and event logs to try to figure out what's going on. It's like we need a happy medium. So like, central logging, how do we do that? How do we get something deeper than X-ray? Is it Dynatrace? I'm leaning more towards yes, something like that. An APM would be nice if I'm in a hybrid architecture where I've got some serverless apps, I've got some container apps, and I got some traditional end-tier apps. I've got one pane of glass, I've got a one agent that can handle it all. I think that'd be amazing. We just got to get there. So it's just time, right?
Mm-hmm. Cool. Hey, what's the last pattern? We got 3 so far.
The last one's called Graph, so it's using GraphQL. It's basically the same thing as we just talked about with the monolithic, but it's 1 or 2 endpoints that are your graph query endpoints. So you have, 2 endpoints pointed to one function, but because you're using GraphQL, it gives you that query syntax, so you're actually passing in queries and telling the API what you want. The pros is low cost of ownership with a scalable graph API. It's pretty fast to deploy. It's another low probability of a cold start. But the cons are, if you don't know GraphQL, that's your first barrier of entry. You got to go learn GraphQL, and then you got to figure out how to apply it into a serverless architecture. And again, because it's a single function, you can hit CloudFormation limits. Debugging and testing becomes complex, and your performance tuning and monitoring is, again, your slowest user is what you got to basically tweak towards your slowest invocation times.
Mm-hmm. So can I ask a question on this? Because that means your Lambda functions basically, just return the data and then use GraphQL on the front end. Or do I get this incorrect? I use GraphQL on the front end to then extract the type of data that the backend provides to me. Or am I get this wrong? Do I get this wrong?
It would be like your front end is talking to a single API endpoint, and it's using like GraphQL queries to pass in and request. So it's still executed server side. It's not like giving you all the data and say filter at client side. It filters at server side and returns the results of your query to you.
Mm-hmm. But GraphQL, obviously, then the framework, translates that query, and then I can then, call certain functions that then really then provide that data set for that particular query, and GraphQL takes hopefully some of the burden off me to do the filtering and returning the right pieces of data elements, right? Yeah. Okay.
I basically set up, here's my query endpoints. I basically map these functions or class methods are to this type, and then it does kind of the routing for you. It gets pretty complex, though. You're mixing 2 frameworks and an emerging tech. I feel like if you're wearing a fedora and you got a scarf, this is for you, because it's super niche and nobody's going to know how it works but you, so you might take pride in that. So I don't want to bash GraphQL too hard. I actually think it's a really cool technology. It's easy to be stupid when you do something like this. It gets really messy if you're not, controlled in your software architecture. The high level of discipline is what we should say in the nicer way, I guess.
Mm-hmm. Cool.
Yeah, I think. Go on, Andy.
No, I wanted to say I think this was extremely valuable, because I think we never in any of the episodes that we had on serverless went into that much detail of the different design patterns, and also, and a special thanks for discussing the pros and cons of every approach. Yeah. Brian, do you have something on this? Because I have another topic I want to bring up.
Well, no, there was a topic I wanted to go to. So it was number 3 about how they get you, but I'm not sure if you have a different topic, let's go there.
If you want to talk about how they get you is like in performance of going serverless.
Well, yeah, you had mentioned a bullet point in serverless cost optimization and how they get you and how you can get around it. Kind of, basically knowing that every business model somebody creates is going to be hopefully to the benefit of their customers, but it's also going to help the business make money, right? And in serverless, there's a lot of pitfalls and a lot of ways you can really get taken. Well, I shouldn't say get taken advantage of, but a lot of things you can do to really not be smart and spend a ton of money, right? So that's kind of the how they can get you. And I think you were going to address a little bit of how you can get around it, how you can make sure you don't do things maybe from standard points, but also from maybe some after you do a lot of serverless. What are some tricks of the trade in order to help reduce costs? And that's where you might have been going with this. That's how I'm interpreting that bullet point, at least.
Okay, and then the other one that you guys wanted to bring up, because I can shoot two off real quick. Let's see what the other one is.
Well, the other one was the fourth bullet point that we had in our preparation list, which was talking a little bit about secrets. But you also said this might be a little longer topic on its own, so maybe we'll take this aside for another episode. Let's go on the cost and monitoring, because I think that's obviously very important. Do we shoot ourselves into the foot if we are doing something wrong and then wake up with a big bill and from Amazon or whatever other cloud provider? So maybe let's talk about this first.
Yeah, I'll do 2 quick points, and then maybe if we have time, just a high-level secrets management stuff, and then
Sounds
maybe
great.
we come back and do that as an episode of its own, like you said. So the 2 points I was really talking about is, the first one is API gateway. It looks cheap on paper, but you start running the numbers, and it disproportionately grows your API costs. I'm not sure what the limit is where it's like, hey, you might be better off just running this in containers. Obviously, it's going to require a very high load, but let's just compare costs real quick. Lambda, I get 1 million invocations a month for free. After that, it's 20 cents per million invocations. API gateway is $3.50 per million. You start getting into the billions of API events a month, and it starts to get pretty expensive. This, what once was super cheap REST API running on completely serverless, it can scale. It starts adding up. So you got to really kind of figure out, if it's running 24/7, so my containers are never really turning off because I've got such high load. I'm hoping I'm making enough revenue that I don't care at this point. But these are just, things to think about. What is the point at which a 24/7 Lambda service running through API gateway becomes cheaper to just host yourself in, say, Fargate containers? Obviously, you're adding more complexity, and you're at the nth degree of optimization. It's just something to think about. If you have a very API-heavy application, you're going to get some extra costs that you might not have thought of. Everybody sees the 20 cents and thinks it's going to be super cheap.
That's interesting, because what you're saying, it sounds like, is that it's not the serverless component that's going to cost you in the end. It's the API gateway, and that's a necessary part. You can't have one without the other.
Yeah, it's
right?
kind of my plea to Amazon to fix their pricing. Like, can we make it $1? Like, come on, let's make it $1 per million.
What is it now? You said $3. Is that
$3.50 per million as of July 24th, 2018? For anybody listening to this in the future.
Why don't they make it? What if they make it $3.49? That'll sound cheaper.
I mean, when you're dealing with billions, 1 cent adds up pretty quick.
Yeah, I know.
I'll take a billion pennies any day.
So, but if you would move, I like that. You say basically, let's figure out which lambdas are running constantly, and then put it to a container and let's run it in Fargate. But wouldn't you still kind of expose your Fargate APIs through an API gateway, or would you then do it?
Yeah, that's why there's 2 levers, right? There's the Lambda runtime. If it's invoking literally all the time, that's going to be an up and to the right, and there's got to be a crossing point where hosting it gets cheaper. Then really my beef right now is just the API gateway pricing. It's a powerful tool, don't get me wrong, but I have virtualized on-demand compute for 20 cents per million, but an HTTP proxy is $3.50 per million. It just seems a little skewed.
Yeah. No, I think my point was, and maybe I get this wrong, my point was, even if you move from Lambda to, let's say, Fargate, wouldn't you still have as a front door gateway the API gateway?
Yeah.
Why not? So that means you're not saving the costs on the API gateway, even if you move from Lambda to Fargate.
Not necessarily, because you could do a traditional ALB or ELB in front of the container, and you could do what you would, to really be optimizing the cost, you'd be taking your logic out of your lambdas and sticking it to more like a a containerized microservice and throwing it up there, so it's handling all of the routing for you. Does that make sense?
Yeah, that makes sense. Yeah, I completely I understand. So basically, what you're saying is you would replace, and this was like what I got wrong. You would replace the API gateway with your own routing that you may run in a container, and then expose the container through some easy mechanisms. And with that, you can save the API gateway for. Yeah, I understand that. Cool.
I'm curious to see if people are actually hitting these problems in the real world. I mean, there's a lot of people doing serverless, like, a Cloud Guru, for example. If you're looking for AWS training, you probably go to Cloud Guru. They're 100% serverless. They even run serverless conf. So these guys are pretty good at it. I don't see them, calling the sky is falling. Here's the dirty secrets of serverless. Let's get off it. No, they promote it. These are just things to think about. I'm not trying to, be a naysayer or a doomsday person.
Right. You might get yourself in a situation where this is something to consider, but it's not a red flag as you're going to run into this and it's going to cost you a fortune. It's just keep an eye on what you're doing, just like anything. Keep an eye on what you're doing and what those costs are so that you can figure out, hey, do we need to optimize and rethink so that we can bring our costs down?
Yeah, it's really just, understand how it works before you just do it because it sounds cool, right? If you understand how it works and how you're being billed, you don't have surprises, because having, 1 billion requests a month going through a serverless architecture is really cool. It's, it's not going to be that expensive relative to the amount of revenue you have and the complexity that you lost from having to deal with all the orchestration of servers and patch management. You're gaining, right? It's just, things to be, cognizant of. The other one that I wanted to talk about is there's some limits in Lambda, right? I can't run longer than 5 minutes. So there's a couple different approaches to how I get around that. The first one is, here's a good example of a product I was working on where I have basically a Bitcoin address you give me, I go pull your transactions, I look it up. I'm basically was trying to do an accounting app for crypto miners so that we could, keep our taxes so that the government doesn't come after us. Basically, when I would pull your crypto wallet, if you had a ton of transactions, if my next thing when my Lambda was, I'm going to go for each one of these and unpack the transaction and figure out how much you gained or spent, well, that very easily hits a 5-minute runtime. So a couple things you can do is, first, let's just break a function out that handles the unpacking and inspection into its own function. We can do a simple for each with parallelism, concurrency controlled by Lambda, and call each one of our transactions into our function. But if you remember back to where I said be careful with concurrency, you can topple people over. So that's not, the most elegant. We could also implement SQS. We could queue something. We could have a scheduled Lambda that, it starts up. Is there anything in the queue? Grab the first one, do it, go back to sleep. And the more elegant solution that I've landed on that I'm really liking, and it's a good hybrid between serverless technologies, is I queue the record, but then I can invoke, using the AWS APIs, a Fargate container that comes online, and its one job in life is to watch this queue, process anything in the queue, and then kill itself when it's done. And so now you got serverless containers with a serverless API and long-running background jobs you're doing in Fargate. It's awesome.
Yeah. And basically what you're saying, and this is, I've mentioned this in previous podcasts when I started building my first Lambda function, and I basically made the mistake of applying my 90s mindset, which was like I learned coding in the 90s, and I did not learn how to do event-driven programming and how to break things apart and chain them together, as you said, through SNS or any other means or queues. I basically ended up with functions doing something very stupid, calling other resources waiting, and then basically I built a string of synchronous functions that I called and ended up paying too much money, and they took too long. And basically what you're saying is there's a lot of smart ways of breaking a big problem into smaller pieces. And then if the smallest piece is still too big, you can still outsource that into a container and let the container do the heavy lifting for these let's say, rare occasions or certain occasions where you actually need to execute longer than 5 minutes. Right?
Yeah, exactly.
Could we call that container as a function?
It's kind of right.
Yeah,
It's pretty sweet.
Yeah.
Hey, Andy, I've heard that story so many times now that I've actually started using it in front of people, and I'm doing so well with it. It sounds like it's my own story, so I appreciate that. I get to now I say, back when I created my first function, which I've never done any. I actually just taught myself. Just so you all know where I stand, I just taught myself Python, which is the first language I really delved into since BASIC in like the mid to late 80s, whatever. So yeah, I'm a bit further behind on the functions, but I can sound like I'm smart with it thanks to you.
I mean, I feel like I just need Andy to follow me around. He's got the sweet accent, and he just recapped what I said in like a more elegant. I'm like, oh, I speak cyborg. He's like, oh, for you other people, here's what he actually said. That's
a talent of Andy's. All right, these have both been really awesome. And I just want to, in the interest of time, I want to push on to giving a kind of an intro to the next topic, if you can give us a higher level of it. But those are some great tips on that. It's amazing how serverless is still in its infancy, but really quickly getting more complex and more adopted.
Yeah, the traction's been insane.
Yeah. But so there was one last topic, right? These serverless secrets, right? Do you want to give us a high level what this is?
I'll just talk about secrets management in general. It doesn't have to be serverless, but where serverless made it exposed, some opportunities to me. It's like I'm sick of people checking secrets into GitHub repos and then they mess up and they check into a public repo and wonder why they got hacked. It's like the most common way people are getting credentials lifted is they're just giving them to people for free, or they've got system files that are storing secrets on disk and somebody gets on the server. It's like, stop.
And what is a secret in general? Can you just even define what a secret is? Because you kind of gave some examples there, but before you mentioned it, I had no idea. I'm like, secrets? What are you talking about? Can you just even give us like a super high level, starting with what is a secret in this context?
To be fair, I had the same, like, what the hell are these people talking about? When I saw it, I didn't realize the industry was calling it secrets management. I've always called it like application configurations, right? So basically it's, your database connection strings, your, API keys, anything that's a secret that you don't want somebody that you don't know to have access to. You want to keep it a secret, right? Mm-hmm. So there's a couple different approaches. This is more of I think almost a 101 conversation for another day, but the three things I want to touch on is there's inside AWS, there's what's called SSM parameter store. It's like a hidden gem in AWS that has become one of my favorite things in AWS. I don't think Amazon realized what they built until it was too late, and the pricing model is free. If you have an AWS account, you have access to SSM parameter store for free. The only thing you get charged for is the API requests, and it's like fractions of a cent. Mm-hmm. I think Amazon finally figured out what they did, and they tried to commercialize and make it more of a product. And they just announced recently AWS Secrets Manager, which takes kind of what you can do in SSM to an extreme. It's a lot more expensive, but it features things like auto rotation of secrets between RDS instances. And then the third thing I want to talk about is one of the things I like to do in serverless is multi-region architectures. And when I'm doing secrets management inside of SSM parameter store, the UI is really clunky. And for the console in AWS, it's region specific. And doing everything from the command line can get tedious. So we built an Electron app at Observian. One of our engineers, his name's Jeremy Zirsi, put together an Electron app. We call it AWS Secret Awesome. It's an Observian app. It's free. It's on our GitHub. It's just github.com/Observian. Anybody can use it. And what it allows you to do is easily copy and paste secrets between regions with just a UI. You click, I want this one in Virginia, hit save, it's there. We're also, working on it as we go. It's an internal tool that we use for our own dev and we give customers. We want to be able to do secrets promotion and some other stuff. It's a free app, so people can't complain too much. They're not paying for it, but if anybody likes it, feel free to use it and hit us up with some feedback. I really want to get the community using SSM parameter store and evangelize, stop doing this stuff in files. How I got to this was in Lambda, you can use environment variables That's the short version. I didn't like that the environment variables are sitting right there in the console, and you can scrape secrets out of it if you have access to somebody's AWS console. So that's the intro, if you will. We can dive into it deeper another day.
Definitely. No, we should definitely do this. Definitely want to welcome you back, because I think this was a wealth of information for many people that are still not yet sure how to get started, maybe before making mistakes or going down the wrong path. I think it's very valuable information that that came out of obviously your experience. Brian,
Yes.
Shall we do it?
Go on.
As always, right? I'll try. So I think what I've learned is while serverless, it's a hot technology and has been for a while, it still feels like we're still lacking a lot of the best practices to stories and also the tooling around. But thanks to people like you and obviously others in the space that go out there, run the meetups, do the conferences, actually do implementations, and share the things that went well, the things that don't went well. What we learned today are 4 design patterns. I really liked the microservice nano pattern, then the service pattern. We had the monolithic pattern, and we have the GraphQL pattern, where each of one of them has obviously its own pros and cons. Thanks for giving us the details. So there's a lot of information out there for people that want to get started, but please have have a look at what people have already done and what they've experienced. I really liked in the end when we touched based on the costs, where I always thought, on the cost perspective, it is the number of Lambda invocations that potentially will kill you if you grow, but it's actually the API gateway that is charged more than factor 10, factor 15 more than what the individual Lambda invocation is per million, obviously. And you gave some great advice on how to offload maybe some of these constantly running Lambda functions behind an API gateway to a container running in Fargate, or building your own router in a container, and then basically replace some of the API gateway's functionality with your own implementation to save costs here. I think for me, this was amazing, even though I also have to say that everything we learned so far from our other guests was pretty phenomenal too. But this was very, very practical, something that we can apply. And some of the websites I think we want to highlight is serverless.com. Then obviously you, Justin, maybe you can remind us again about the GitHub page of the secret tool. What was that again?
Yeah, so one of the things you can just do is go to observian.com, and in the right-hand corner, just click on Tools. It's got a secret awesome page right there that links up to our GitHub page.
It also has your blog there as well, your Observian blog, which has some cool-looking articles.
Yeah.
And you can also follow me on Twitter at Justin Donohoo. My name is pretty unique, Donohoo. Just put that in there. You should find me.
Yeah. Cool. Yeah, that's it from my side. I definitely want to have you back. There's more to talk about on secrets, and I'm sure there's a lot of other stuff that that will be great information for our listeners.
Yeah, for sure. I mean, thanks for having me. If you guys want to talk about secrets, you want to get into containers, there's a vast topics of Wikipedia in my head that we can talk about when it comes to tech. I like to tell people I'm like a technology therapist. Tell me what your problems are, and I'll help you make them better, or maybe I'll make them worse and you find somebody else.
Yeah, I've got some secrets I want to talk about, but I don't know if I'll get to stay living in my house if I do.
Yeah.
So
you want to protect those secrets.
Yes, I do. And I want to thank you as well, because this is, I think every serverless show we have is completely different. And this, as you said, Andy, this is going into a whole new era of it. Everything is so brand new still with serverless, even though it seems like it's in, I guess, today's pace, it seems like it's been around a while and people are starting to really talk about it. There's still so much knowledge to share, and thank you for sharing that as well. In terms of the tooling, I think we can all agree that there's got to be a lot more. For fans of Dynatrace, we've got some stuff going on. We've got more coming all the time. So keep an eye on that, because obviously if here's me, Andy, the first time ever, I think, maybe promoting Dynatrace on the podcast. As we said before, you can have a million tools, but if you can have it all integrated into maybe 1 or 2 platforms, it's going to be much better. So keep an eye on what we've got coming out. But in the meantime, everyone's got to get up and running and as efficient as possible. And hopefully we can have more and more people sharing little tips and tricks, and we all get better as an industry and as all individuals we share and be happy.
Yeah, and I think it was awesome. And that single pane of glass for Dynatrace is kind of like the dream scenario. And, when we say serverless, it's not always just Lambda functions. There's containers, web storage, compute, database, analytics. There's a lot of things to talk about. So people just got to be careful when they say serverless. You could mean like 50 things. So just make sure that people are communicating clear ideas.
Awesome. All right, well, thank you for coming on. We look forward to having you back on, and we're going to discuss some secrets. Maybe we'll have to get some sort of a Dear Diary music for that one, Andy.
Yeah,
That'd be sweet.
Dear Diary.
All right.
Yes, all right. Thank you very much. We'll all talk to you soon. Anybody has any questions or feedback, please shout out us on Twitter at pure_DT, or you can be old-fashioned and send an email at pureperformance@dynatrace.com, and you'll be the first one to do it if you did, because I don't count our old friend Rick's incorrect question. Way back in the first few episodes, we had some trivia questions, and he guessed wrong. But any feedback or topic ideas, we'd love to hear them. And thanks everyone for listening. Bye-bye.
Bye.